Hi, this is Riley Benavides. This is my lab for my CECS225, Section 2 with Susan Nachawati. This is going to be my ALU lab. I will get started. So I will start off with just by saying the ALU is going to be a device using multiple different devices to do things such as compute ands or ors or adders or subtractors, or in this case we have set less than and we have mux as well. So we are actually implementing many different other labs that we have done in the past, because our adders and our subtractors are going to be using the half adders, the full adders, and the ripple carries. So we have all those open right here. I'm not going to go over the adder or subtractor because we have already done that in previous labs. So I will start off with our first device that we're implementing in the ALU, which is going to be the AND A. And you can see right here that I have two inputs for it, A and B, and an output of Y. And then it's exactly what the name says. There's 8 bits, so we're going to have 8 ANDs. And yeah, and then we're going to go to this OR, which is basically the same thing as the ANDs, just with the OR gates. We have inputs AB, output Y, and then we have 8 different ORs. And then right here, I named this one SLT8. It's going to be the set less than with 8 bits. 2 inputs, A and B, and then we have Y right here. And then set less than is pretty simple. Basically, if A is less than B, then we're going to have an output of 00000001. And if A is greater than B, then we're going to have an output of 00000000. So just an output of 0. And then we're going to go over to our mux, which we've made a mux before, but this is another mux that we're implementing. It's going to have 8 inputs right here, and then 1 selection input, and an output of Y. And then you can see right here that we're setting each different input for whatever selection is going to be, and then an output as well. And then moving on to the ALU, where we implement all of our devices, we're going to have a function select input for just the mux. We're going to have AB input for all the other ones, and for and then we're going to have a 0 flag output, and then we're also going to have a result output. So we're going to wire some outputs for our AND gates. This is going to be our AND gate output, and AB, our OR output, or AB, our add output, add AB, our subtraction output, sub AB, and our set less than output, SLT HB. I don't know why it's H. Could just be A. But yeah, right here we are just creating an instance of the AND 8-bit with inputs AB and our output AND AB. Our OR 8-bit with inputs AB, our output OR AB. We have our adder, which is going to have our our carry in as B0, and our AB as our other inputs, and our add AB as an output, and then our carry out we left blank. We're going to have a subtractor with 8 inputs. It's going to have the carry in, and then it's going to have inputs AB and an output of sub AB, and also a carry out. And this is going to be our set less than 8-bit, which has the inputs AB, and then our output set less than output AB. And then we have our 8-bit mux, which is going to use our outputs from AND or add, and then 3 different ones, and then our set less than, and then it's going to have input of function selection, which we showed before, and our output result. And then we have 8 NOR gates right here for our 0 flags and their various different results. So I already ran it, and my computer goes really slow. So I am just going to show you really quickly the schematic that we have for it. So as you can see right here, we have our function select, which only goes into the mux. Our ABs right here is going to be our inputs for the AND, the adder, the OR, the subtractor, and the SLT. And then we can see that they each have their own outputs that lead into the mux. And then our mux here has the 8 inputs, the selection, and then it's going to have the 8 NOR bits feed into it as well. And then our result right there and our 0 flag as well. All right, and then we have our timing diagram. I'll run the simulation real quick. I'm going to put this in the background so I can go ahead and show you my code for the test bench. Yeah, we have our inputs AB, function select, and our outputs result 0. And then we are testing 000001111 for B and 010111010 for A. And yeah, these are going to be the displays that we're having for each test. And I'll show you the output as soon as it loads. All right. So right here we have our timing diagram. which I'll put into full scales, put to the beginning, and show you the full size of it. That's going to be our timing diagram right there. And then we have our outputs. Oh, it's up here. Don't know why it's all the way up here, but so as you can see, the AND function, it tests 0, 1, all those binary numbers. Wherever it's two ones at the same time, it's going to have a 1 right here, so it looks right. And then our OR function is only going to have a 1 if there is a 1 happening to be in either one. And then the addition function is 010111010 plus 000001111 is equal to 011011001. And then if you subtract the two, it's equal to 010011011. That is true. And the set less than function, this A is going to be greater than B. And I said that before, when A is greater than B, it's going to be 0. So we have 0 right there. And yeah, thank you for listening. And I hope you guys have a good night.